let us first define what is complex number first. Correct? What is complex number? Yes, it is a number of the form z. It is written as z, that is e plus ib. Correct? E plus ib or e plus bi, whatever you see. E plus bi. Correct? Where a is called real part, of z, and b is called imaginary part. Correct? Or you can also define complex number, uh, or I will write can be defined as ordered pair x comma y of real numbers. That are to be interpreted as points in complex plane. That means what? If you want to plot this x comma y, and ye x comma y is same as x plus iy. करेक्ट? यू मस्ट अंडरस्टैंड कि दोनों सेम है, दोनों नोटेशन सेम है. करेक्ट? इन आर कॉम्प्लेक्स एनालिसिस दिस थिंग. करेक्ट? और this is imaginary part. So what is your I? Let us learn something about I. I is called iota, and what is the value of I? I is equal to square root of -1. ठीक है? एंड इफ यू आस्क कि ये कॉम्प्लेक्स नंबर किसने मतलब फाइंड किया, देन कार्डानो इज द वन हु फाउंड आउट. कार्डानो के बारे में सुना होगा तुम लोगों ने. ही हैज़ गिवन यू अ फॉर्मूला टू फाइंड द solution of quadratic solution of cubic equation. If you are having any cubic equation, say x cube plus ax square plus bx plus c, then he has given you a method to solve this and get the roots of that. What he used to do in the first step, he used to substitute something. He used to replace x by something, so that this a gets 0. A will become 0. Then your equation will be of this form, that is x cube plus some, say, kx plus some l. Then it is easy to find this better than that. So this was the rule of Cardano. We'll later on see क्या है rule, कैसा है. Okay, so if I say z equal to x comma y, then you must understand this is same as x plus iy, and real part x is equal to real part को मैं re of z लिखूंगा, and y को imaginary part that is im of z. मोस्टली यही नोटेशन वर्क करेंगे हम लोग हर जगह. And when do we say two complex number is equal? Say z1 is equal to x1 comma y1 and z2 equal to x2 comma y2. When do we say z1 is equal to z2? Yes, or you can see whenever when do we say two coordinates are equal? Yes, when your x coordinate of both the thing must be same as y coordinate, that is if and only if x1 is same as x2 and y1 is same as y2. Correct? Is that clear to you? Or if you don't like this thing, then you can write like this: x1 plus I y1 is same as x2 plus I y2. Correct? So real part must be same as real part, or you can take real part together and take imaginary part together and compare them. Correct? You can do like this also: x1 minus x2 is equal to I times y2 minus y1. So here it is imaginary part, here it is not imaginary part, so x1 must be same as x2 and y2 must be same as y1. Okay, next thing comes how to plot complex number. So to plot a complex number, that is, let us take z equal to 1 plus 3i. How to plot this? If it was in Cartesian, that is 1 comma 3, then it was easy to form, easy to plot. Correct? Here also it is same thing. The thing what will change here, in earlier case this was your x-axis, this was your y-axis. Now this is not x-axis, this is real axis, you can say, and this is imaginary axis. Okay, so real axis means what? This will take real part of the complex number and this will take imaginary part. If I write, this will take something x here and this will take iy. Correct? So 1 plus 3i, we can plot it as 1 unit here and 3 unit here, 1 2 3. So something here, so this point will be your 1 comma 3, which is same as 1 plus 3i. Once you write of this format, तो तुमको डायरेक्ट दिखेगा कि हाँ कोई प्रॉब्लम ही नहीं है कॉम्प्लेक्स नंबर को लिखने के लिए. करेक्ट? सो यू सी, अगर मैंने ये फॉर्म में लिखा तो इट इज़ क्वाइट क्लियर दैट योर कॉम्प्लेक्स नंबर इज सेम एज आर क्रॉस आर. करेक्ट? एंड ऑर्डर्ड पेयर पहले ही मैंने बोला था, दैट इज यू कैन नॉट चेंज द ऑर्डर ऑफ दिस. पहले 1 and 3 लिखा, सो दिस इज नॉट सेम एज 3 and 1. करेक्ट? Yes. Now let us define sum and product of complex number. So sum, that is, if z1 is equal to, you can say, x1 y1 and z2 equal to x2 y2, then what is their sum? Z1 plus z2 will be, you can write like this: x1 plus I y1 plus x2 plus I y2. Then their addition will be take real part together, that is x1 plus x2 plus I bracket open y1 plus y2. So what will be your z1 plus z2? That will be, first coordinate will be x1 plus x2 comma y1 plus y2. So this is the addition. Now if the question is product of two complex number, product, that is, you want to find z1 cross z2. So again you have to write like this. See, here the case is you cannot do direct multiplication, that is direct whatever you used to do in the case of dot product. You cannot do that here. Correct? Because you haven't defined dot product here. So you start with x1 plus I y1 and this is x2 plus I y2 and try to multiply this. If you multiply, you will get x1 x2 plus, if you x1 I x1 y2 plus I y1 x2 plus I into I will be I square. I'll write here, this will be I square y1 y2. So now what is your I square? You already know your I is -1, so I square will be -1. I is root of -1, I square will be -1. So if you put it here, take real part together, so this will be x1 x2 minus y1 y2 plus I times, take the bracket, it will be x1 y2 plus y1 x2. So if you write it in the coordinate form, then it will be x1 x2 minus y1 y2, and this will be comma x1 y2 plus y1 x2. Yeah, so this is your z1 z2. In the case of metric space, I think एक example किया होगा तुम लोग ने, where metric is defined like this. Distance between metric x comma y will be defined like that, and you are asked to check whether it is metric or not, and वो metric होता है, and that metric is your complex number. Okay, we'll do that. Don't worry about that. Okay, so this was the addition, subtraction, and yeah, let us see if you multiply टू कॉम्प्लेक्स नंबर और सेम थिंग जो भी रियल के केस में जैसे हम लोग करते थे. इफ़ यू वांट टू फाइंड z स्क्वायर देन यू नीड टू मल्टीप्लाई z into z. If you want to find z3 then it is better to find z square and multiply by z, whether you multiply 3 times or not. But you need to realize one thing कि if you take product of two complex number direct अगर लिखना है तो you don't have to do all the time. It is better, since we are going to do complex analysis, it is better to follow this method. Your real part will be x1 x2 minus y1 y2, and imaginary part will be x1 y2 plus y1 x2. So it is better if you remember this thing, because we will be using all the time. Yes. Okay, so now we are having two operations, correct? So we must have many properties with that. The first one is addition and second one is multiplication. So what is the first property? That is commutative law. What is commutative law? That is z1 plus z2 is same as z2 plus z1, and same thing for product z1 into z2 is same as z2 into z1. Correct? So this is the commutative law. What is associative law? What is associative law? If you remember, that is a bracket exchange, correct? z1 plus z2, let me write like this, plus z3, that will be same as z1 plus bracket open z2 plus z3. Okay, and what is next thing? z1 z2 into z3 bracket exchange, that will be z1 into z2 z3, something like that. This was associative law. Yes. Next, one more thing is distributive. What is distributive law? That is, if you see z into z1 plus z2, that is same as z into z1 plus z into z2. Correct? This is your distributive law. Yes. Okay. So now the next thing is that, can you find if you are given a z, can you find some z inverse such that z into z inverse is equal to 1? The question is this: can you find inverse in complex number? Correct. One is true that maybe I should go little bit earlier. What is the identity element of addition? That is additive identity. Additive identity. What is additive identity? Yes. If you know the real number system, how does this defined as? That is z plus something must give me that something. So what is that something will work here? 0 will work, correct? See, 0 is not 0 here. 0 is 0 plus 0 I. I hope you understand. If you write just 0 and 0 plus 0 I, this guy is same as 0 comma 0. Both are not same here. If you see, the notation is same, but you must understand कि सिर्फ 0 लिखा है, but it is in complex number. You must understand this is 0 plus 0 I. Correct? It looks like same, but uh, somebody may question you that ये तो real number है ऐसा. So, but every real number is a complex number, so that is not an issue. So z plus 0 plus 0 I, that is your z. So what is your identity? 0 plus 0 I is identity, additive identity. Or you must write 0 comma 0. This is your additive identity. Okay. Now if you are having additive identity, so you must give me an additive inverse, correct? Additive inverse. What do you mean by additive inverse? That is z plus something that should give me additive identity, that is 0. But what is my 0 here? 0 plus 0 I will all the time I'll write this so that you must understand key it is not just normal 0. We are working in complex numbers, so I'll give the preference to I also. I can also write it as just 0, but both the things are same here. Okay, so what will be that z plus something that will give me I? Try to see what is your z. Z is x plus iy. You need to add something that gives me 0 plus 0 I. What will be that addition? So you need to kill both the thing, that is you need to kill that x and you need to kill this y. So this x can be killed if you add minus x, so this is gone. And if you want to kill iy, then you need to put minus iy. So what is that complex number? If you take minus outside, this will be same as minus z, correct? So minus z is your additive inverse. So same thing जो भी पहले था, इसमें कोई अलग नहीं है, correct? So this is your additive inverse. Now the next is multiplicative identity. What is multiplicative identity? That is z multiplied by something must give me z again. So what is that something here? Correct? Can you give me that something? That definitely is 1, correct? But it is better to write 1 plus 0 I. Since you are doing in complex number, you can always write z into 1 is equal to z, but it is better to write z plus 0 I. So z plus 0, 1 plus 0 I, that will give me z. So what is the multiplicative identity? You can write as 1 comma 0, and that is same as 1 plus 0 I, and that is same as 1. That is your multiplicative identity, correct? Yes. So next question will be whether does this multiplicative inverse exist? Inverse, that means whether if you are given z, that is say e plus ib, can you find z inverse such that z into z inverse must give me 1 plus 0 I? Can you do that? And whether does this exist for everybody? Whether does this exist for everybody? Or let us quickly start. Suppose z inverse is x comma y, correct? So what will be your z into z inverse? That is given by 1 plus 0 I. So what is your z into z inverse? I'll write it as 1 comma 0, and z into z inverse, you already know how to multiply this. I hope you know that. or you can do multiplying by opening the bracket, or if you remember this thing, that is x1 x2 minus y1 y2, and next is x1 y2 and y1, that is you just have to multiply real part and subtract with imaginary part. So what are the things here? We are having z here, z inverse here, real part is ax, so it will be ax minus, it will be by, correct, and the next part will be ay plus bx. I hope that is clear to you. Now you just have to compare, that is two coordinates are equal, that is you have to compare that ax minus by, that is same as 1, and ay plus bx, that is same as 0. Do you see two equations in terms of x and y? Can you get the value of x and y by solving them? That is linear simultaneous equation, you can say, correct. You can get the some value from here and put it here, get the other one. Yeah, so let us complete that. So suppose you want to find the value of y, so what will be your value of y? Y will be minus b upon ax, correct. So substitute it in this one, minus b by ax. So this is ax minus by, so minus b by ax, that is minus b by ax, this same as 1, correct. Am I correct? I'm putting at the place of y this value minus b by ax, so this will be this. Now can we get the value of x? So this will become minus minus plus, x is outside, I can take it outside, so this will be a plus b square upon a, correct, and that is 1. So what will be the value of x? It will be a upon a square plus b square. So this is your x. Can you get the value of y? What is your y? Minus b by a into x, minus b by a into x. If you put the value of x, you see e and e get cancelled, so you will be having minus b upon a square plus b square, correct. So what is your z inverse? I'll write z equal to e comma b, so z inverse will be e comma e upon a square plus b square and minus b upon a square plus b square, correct. Or if you don't like this format of writing, then you can write z equal to e plus ib, then z inverse will be, it will be a upon a square plus b square, and it will be minus bi upon a square plus b square. Perfect. Is that clear? Yes. So this is your inverse, and whether inverse exists for every complex number, whether inverse exists for every complex number, what will be the issue and when will that issue will come? What if your complex number is 0, that is 0 plus 0i, that is real part is also 0, imaginary part is also 0, what happened then? Yes, you see, inverse does not exist because in the denominator you will be having 0, in the denominator you will be having 0. If one of them is 0, then that is okay. If your real part is 0, imaginary is not 0, then that is okay, you can get that. But if it is the case that both of them is 0, then your inverse does not exist. So this is the main condition. Is that clear to you? Okay, so once you are having addition, multiplication, so definitely you must ask, sir, what about subtraction and division, correct. So once you are having inverse, so एडिटिव आइडेंटिटी भी है, तो सब्ट्रैक्शन z1 माइनस z2 कैन बी रिटन एज z1 plus minus of z2. What is minus of z2? That is additive inverse of z2. So you are having subtraction also. Can I have division? Z1 by z2, that is equal to z1 into z2 inverse. Correct? What do you mean by z2 inverse? Z2 you are having already. The one thing you need to make sure that z2 must not be 0. That is 0 plus 0 I. That should not be 0 comma 0. Correct? This is the condition you must ensure. Then you just have to find z2 ka inverse, and you already know what is the inverse. That is a upon a square plus b square minus bi upon a square plus b square, and you just have to multiply both the things. Correct? So it is better if you remember this thing कि z है तो उसका इन्वर्स क्या रहेगा, प्रोडक्ट क्या रहेगा. इट विल यू डोंट हैव टू डू ऑल द टाइम, बिकॉज ब्रैकेट ओपन करना वही काम बार बार करने से बेटर है टू डू इट ओनली वंस. करेक्ट? Okay, now let us do some questions, some basic questions. Show that real part of iz is same as minus of imaginary part of z. Okay, and one more I'll give. Show that okay, so next question is show that imaginary part of iz that is same as real part of z. Can you do it quickly? Start with the first one. So what is your z? You can start with z equal to e plus ib. Correct? So what will be iz? Or I will you can write like this: z equal to a plus ib. What is your a? A is real of z, and what is b? B is imaginary of z. Correct? Now let us see what is iz. Iz is ia plus I square b. So what is I square b? I square is minus 1, so this will be minus b plus ia. Correct? So what is real part of iz? Yes. And what is the imaginary part of iz? Imaginary part you can see it is a, real part you can directly see it is minus b. Perfect. So do you see some relation between them? Real part of iz is same as minus b, that is minus of imaginary part of z. Correct? And what about next? Do you see some relation here? That was your second question actually, if you see. So what you are having, both are same. Do you see? Imaginary part of iz is same as real part of z. That was your second case, so we already did here. Imaginary part of iz is same as real part of z. Good. Okay, so we cancel that. So now the question comes: can you solve quadratic? Okay. Solve the equation. Maybe I'll give. Solve the equation z square plus z plus 1 equal to 0. Can you give me value of z? And how to do that? How should you do? And I think most of you must be knowing what is the answer. What is the answer for this? Yes? The thing is that all the time you must be seeing this as x square plus x plus 1 is equal to 0. Now I'm putting it as z square plus z plus 1 is equal to 0. That's it, nothing else. Yes, how to do that? You can start with like this. Put z equal to x comma y, correct? So if you substitute here x comma y into x comma y, that is product of two complex numbers, then plus x comma y, and last one is 1, that can be written as 1 comma 0, and that is 0. And you know how to multiply two complex number, correct? Do you know that? How to multiply? Real part multiply with real part minus, so it will be x square minus y square comma, what is the next one? X multiply y multiply, so it will be 2xy, correct? If I'm not wrong, just verify. And this will be as it is, x comma y, and this will be plus 1 comma 0, and that is 0. Now you just have to combine together 0, that means it is 0 comma 0, huh? Here also. So now you just have to compare both the thing. Here you are having x square minus y square uh, plus x plus 1, and here you are having 2xy plus y is equal to 0 comma 0, correct? So you just have to solve both equation and get the value of x and y. Okay, yes. So this will be having x square minus y square plus x plus 1 is equal to 0, and here you are having 2xy plus y is equal to 0. So you see यहाँ पे अगर मैंने y कॉमन लिया, so you will be having y bracket open 2x plus 1 is 0. So any one of them must be 0. But what if अगर मैंने y को 0 बोला तो? If you are giving y is equal to 0, then 2x plus 1 कुछ भी रहा कुछ फर्क नहीं पड़ता, but that will give me a condition that जो भी मैंने proof किया that is true only for 0, जिसका that is true only for a real number, correct? But you already know something, this does not have any solution in real number. That means if you put y equal to 0, correct, then this equation will be your x square plus x plus 1, and you already know that does not have any solution in real number. So your y must not be 0. So what must be 0? 2x plus 1 must be 0. So what is the value of x? X will be minus 1 by 2. So x will be minus 1. Oh, I'll write it here. So you are having x is minus 1 by 2. You are having value of x. You just have to substitute in the next one. You'll get that. So what is that? X square minus y square plus x plus 1. Plus x plus 1 is equal to 0. So put the value of x. So it will be 1 by 4 minus y square minus 1 by 2 plus 1 is equal to 0. Solve this and get the value of y. So क्या आएगा ये? Will be 4. If you put y square one side, you will be having this is 1 and this is minus 1 by 2. So this will be minus 2 and plus 4 upon 4, correct? So I hope I'm not wrong. So this is y square is 1 minus 2 is minus 1, so 4 minus 1, so this is 3 by 4. Am I correct? Yes. So what will be your value of y? Y will be plus minus root 3 by 2. So you are having value of x and y. So what will be your final answer value of z? That is minus 1 by 2 and comma plus minus root 3 by 2. That is same as minus 1 plus minus root 3 by 2. And if you remember, this is your omega and omega square, correct? So I just solve that cube root of unity हम लोगों ने solve किया, but in different sense. Do you see यहाँ पे मैंने कहीं पे भी quadratic use किया? I just doing normal complex का अभी तक जैसा मैंने multiplication सिखाया वही सब use करके हम लोगों ने solve किया, correct? But here you can directly use quadratic. Direct quadratic use करता, that is also okay. I just wanted to give you exercise to multiply this thing and solve. Do you see यहाँ पे आने के बाद क्या प्रॉब्लम होता? यहाँ पे आने के बाद if you put y equal to 0 then this z will be a real number. So your second condition, इसमें अगर y 0 बोला तो you will be having x square plus x plus 1. So here अपने को देखना पड़ेगा कि whether the solution exists or not. But solution does not exist. Why it does not exist? Because if you see discriminant of this, so that is less than 0. That is b square minus 4ac. So that is less than 0. But in short, quadratic equation अगर solve करना है तो you can use formula method also. There is not a compulsion कि यही method follow करना है. Here we just try to directly do that. That's it. Okay. Now let us see a beautiful property. Or let me define whether I should define or not. Yeah, I'll define that. Conjugate of z. Definitely defined as if you are having z equal to e plus ib. So what is your z bar? It will be e minus ib. Perfect. So, and do you see one is a plus ib, one is a minus ib? It is better to just multiply and see what happens. So once you multiply z into z bar, it will be e plus ib multiply with e minus ib. So that gives you e square minus ib the whole square, correct, as per the formula. But that is e square minus I square b square. What is your I square? Minus 1. So this will be e square plus b square. And do you see this is a real number, correct? So you can convert any complex number in real number by multiplying it with your conjugate. Do you agree? Do you see the beauty of this conjugate? If you multiply the complex number with its conjugate, that will give you a real number, correct? So this will be very useful for that. We'll see some example कहाँ पे mostly ये use होता है. Yeah, let us do some 11th standard problem. That is, if it is 4 plus I upon 2 minus 3i, this is what you want to solve, correct? So अभी मेरे को क्या करना रहेगा, ये जो denominator है, since it is a complex number, I cannot do anything, correct? The best thing will be to make this as a real number. If you make this as a real number, then you are done, then you don't have to do anything, correct? So how can you do that? Or one more way is to find inverse of this. So inverse find out karo, or better to make this as real number. So this is a complex number. What will be the conjugate of this? 4 plus I upon 2 minus 3i. The conjugate will be 2 plus 3i. So you just multiply with 2 plus 3i both the side, in the numerator and the denominator, correct? So once you do that, numerator में you just have to multiply two complex number. You know what is the answer, correct? What is the answer? 4 2s are 8 minus 3 plus I into what is the next term? 4 into 3 12 plus 2. I hope you understand मैं डायरेक्ट कैसे मल्टीप्लाई कर रहा हूँ. एंड यहाँ पे क्या आएगा? दिस इज 2 स्क्वायर प्लस 3 स्क्वायर. सो डू यू सी द आंसर? What is 8 minus 3? So it is 5 upon 4 plus 9. 9 plus 4, that is 14, na? Or 13. 13. And what about this? Plus I into 14 upon 13. 14i लिखना है तो that is also acceptable. जो भी तुमको अच्छा लगे. You want to write 14i 113, or in our form that is 5i13 comma 14/13. करेक्ट. और इवन इनवर्स तुम लोग डायरेक्ट भी निकाल सकते थे इफ यू रिमेंबर दैट फॉर्मूला. और दिस वन इज ऑल्सो बेटर. वट एवर इज ओके टू यू, you can do that. So this was the use of this complex number. Yeah, let us see one more thing. Binomial. Binomial formula for real number, it is same for complex number also. That is when you are having z1 plus z2 raised to n, so its value will be summation ncr z1 raised to r z2 raised to n minus r. Correct. So your summation r will start from 0 to n. Correct. So this was same वहाँ पे जो था इधर भी वही है, कुछ अलग नहीं है. And how this NCR is defined? NCR is n factorial upon r factorial into n minus r factorial. Correct. So that's why this is your binomial expansion, same जो उसके लिए था and इसके लिए भी. If you want to prove this, तो proof कैसे करोगे? If you want to prove this thing, if you want to prove binomial expansion, binomial theorem, maybe I'll give you homework. This will be homework for you. Prove binomial formula for complex number. How will you do that? How will you start? Anyone? Yes. Once you see something is true for n, that is for natural number, the obvious way is to do by the method of induction. So you must start with method of induction, correct? Try to do this. Try to prove, and if you are able to do, then just send me the solution. Okay. Maybe I'll stop